Welcome everyone to this special video tutorial for EW200 for your circuit board design that we're doing in class. Let's first start with a new project and label this EW200 board and double click on that once it loads so that we're in the work environment. All right, so first thing we need to do is create a new electronics design. So we're going to click this drop down on File and go to New Electronics Design. And we get this kind of blank page. And we're going to click New Schematic, which opens up this menu or this window here where we're going to start to build our schematic for our board that we're making. Now, we need to put a Raspberry Pi Pico in this, which isn't a default in Autodesk Fusion. So we're going to go to github/zc-techdraft. And if you go there, and I'll link this in the description, but if you go there, you'll have this link here, this Fusion Electronics Pi Pico library that I created. Click the drop down on code and click download zip and download it to your computer. And then open that up. And that will be a zip file, so you can then drag it to, say, your downloads or whatever, so that you have the actual unzipped files that you want. So we are going to go ahead and upload some of these to our folder. I'm going to click New Folder and create Electronics Library. So this is going to hold all the components that we have to make for this project. And then the general folder will just contain the overall board and schematic. I'm going to double click on library. I'm going to click upload, select files, go to that file, and you want the Pico package through hole v3. I'm going to hold control and also select this Raspberry Pi Pico library. The SMD and the V2 are other types of Pico boards that are for like surface mount soldering or something, and we only want the through hole one, so we're going to just upload that one. All right, that's going to take a minute to upload. And you can see now we have a Pico, Pico through hole with headers already attached to it, and then a Pico library as well with the component, with the symbol, and the package for through hole. Now, our Pico package through hole isn't linked to the 3D model. So I'm going to right click and click create new 3D model. Click save. And I can just drag this Pico package through and drop it in there. And that should be lined up. So I'm going to click finish. And now that is linked to it. So if we go back to our components, we see under Raspberry Pi Pico, Pico package through, we have the correct, we have a board attached to it. All right, we're going to upload this all to library.io. And you can just click create. And this is going to put everything on a web server so that you can access it a little bit easier, maybe down the road if you need to. All right, so let's close some stuff here because we don't need it. And we're back in our schematic. So let's go ahead and place our Pico first. So I'm going to click this drop down and go to Pi Pico. And I want the through-hole version, and it's saying it's not linked to the 3D model, so I'm going to have to fix that. But let's first place our Pico in our schematic. And I'm going to go to Document, Line, and I'm going to draw a box. So I'm going to go to Info and draw a box. So we're going to want a box around each of our sets of components so that we can kind of keep them labeled. And I'm going to put text here that says Pi Pico. And maybe make that a little bit bigger. So I'm going to click Inspector and change my size to, say, 0.15. That's a pretty good size there. All right. Now, we need to add a few things to this. So we have each of our GPIO pins. We have our V-bus and V-sys, our 3.3 volt out, and our ground. And we need to attach some of these pins. So I'm going to click my drop-down and place components. And I'm going to go to Power Symbols. And I'm going to place a 5 volt symbol up here. Click OK. 3.3 volt symbol up here. Click OK. And then I'm going to scroll down to G and D for ground and place that down here. All right, let's go back to design. And nets are like wires. They're the connections that you make. So I'm going to click on this. And I'm going to click my VSys to 5 volt. And my 3.3 volt to 3.3 volt. And my ground to ground. Now, there are some GPIO pins that we're going to use to control everything, but we don't really know what those are yet. So we're going to leave those blank, and we'll add to them as need be. So let's go ahead and first place our component being our potentiometers. So we're going to have 2 potentiometers on this, or variable resistors on this, so that we can change color of something or to have them be really any input we want. So go to potentiometer _ trimmers. And we're going to go down to this 3310Y-001-104L. And I'm going to place 2 of those. Now I want to rotate this. So I'm going to right click to rotate. And I'm going to place 2, as I said. And press escape to get out of the command. All right, let's go ahead and go back to document and line. And make a box around them. I'm going to borrow this by Pico, copy and paste. And change that name to POTS. POTS is the short for potentiometer, or POT is the short for potentiometer, and we have 2, so POTS. All right, go back to design. These have a value to them, a resistance value to them. So I'm going to click value and click on the resistor. And it's saying it doesn't have a definable value, but that's not really true. So we're going to click yes, and we're going to label this as 10K. And then do the same for the other one. All right, so on the top, we're going to have 3.3 volts. On the bottom, we're going to have ground. Usually you have ground going down and power going up. So I'm going to select this 3.3, copy it, and paste it a little bit above each of these. Borrow my ground, copy it, and paste it a little bit below that. Let's go ahead and hook up those nets. And then we're going to come off of this, and we're going to just click and click escape after we have a short line. And these are going to be hooked up to some of our GPIO pins so that we have an input for the potentiometer. So let's go ahead and name that GPIO pin. So I'm going to click name. I'm going to click on the line. And I'm going to label this GP26. Now, these are analog components. Being that a varistor or potentiometer puts out a range of values, not just ones and zeros. So we need to make sure that we go to one of our GPIO pins that can handle a analog device. And so GP26 is one of them. Also, GP27 or GPIO27 is another one. All right, so let's come up and put the names on here too. So I could theoretically just draw a wire that connects like, that, but that is pretty messy having that all over the board. So instead we use names. And so like this 3.3 volt is a name, and this is saying that anything that's connected to that, so like this up here, this down here, those are all sharing the same wiring connections. So GP26 is going to share a net with GP26. And I'm also going to place one for 27. And then I'm going to go to name and name those GP26 and 27. You can see it comes up with them. And then click yes, you do want to connect those. So now this wire coming off here is connected to this wire here. And this wire here is connected to this wire here, just because we named them the same thing. All right, we're also going to have a surface mount LED that we can turn on and off. So I'm going to go to LED. I'm going to make this just a little smaller because we don't need it to be so big. And it is a green LED. And then we can select the variant. So this is the size. 0402, 603, all the way up to 1206 are sizes for surface mount components. And we want 0805. It's important that you select that 0805. And I'm going to place that just below my Pico. Now you need a resistor in series with the LED. So I'm going to go to resistor and select R. Click the drop down, go to 0805 again. Rotate it by right clicking and place it just below it. Now we need a ground below that. And then let's hook everything up. So we're going to connect the resistor to ground, the resistor to the LED, and then I'm going to come up and place a little tab here so that we can name this. This is going to go directly to a GPIO pin, GP15 to be exact. So that means we should label it up here as well. I'm going to click N on my keyboard to go to name and name this GP15. And yes, I want to connect it. All right, let's draw a box around our LED. I'm going to borrow this name, place it there, and I'm going to change this to surface mount or SM LED for surface mount. All right, so we have two more components that we need to add. We need to add a small buzzer, and then we also need to add a 3-pin or 4-pin really LED that can do red, green, and blue. The problem is those devices aren't in our libraries. Now, we can probably find them, but it's a little bit hard to find a library sometimes, and they're not always made very well. And so I often like to just make my own library items. So if I go to the internet and I go to DigiKey, which is a common supplier for electronics components, this is where we bought everything for this project, I can search 102-3764-ND, and that's going to get me this buzzer. So this is the exact buzzer that we are using on our board. Now, there is some information here for just making sure it's the right buzzer, but we want to go to the data sheet, and this is going to have all kinds of information. So the data sheet is kind of where you always want to go for your components. It has our rated voltage, which is 3.5 volts, minimum of 3 volts, maximum 5 volts. That's good because our buzzers are, or our Pico puts out 3.3 volts, so that's close enough. And then if we continue to go down, we have our mechanical drawing here, and this is what we are going to need to make a library item. So back in Fusion, I'm going to click File, New Electronics Library, and I'm going to create a new symbol first, and I'm going to label this CMT-1285C-035. So that's the name of the buzzer, and then I'm going to underscore buzzer. Oops. And then we can place, or we can draw the symbol for our buzzer. Now, a symbol for a buzzer is pretty simple. We first want a pin, so this is what we connect to. I'm going to put one pin here, one pin there. So that's like our input and our output pins. Press escape. And then we're going to draw our buzzer. So I'm going to click on line. I'm going to come one line or one box below my line. I'm going to come up. And then I'm going to switch to a curved line. And I'm going to kind of mess with it until it draws in the correct direction that we want. So we're just making a half circle. Now you can also, instead of doing that, because that's kind of a pain, you can create an arc. So I'm going to click on my starting point, my ending point, and then draw the arc. So that's probably an easier way to draw that. All right. Now this is it for our symbol. We have an IO pin coming out. We have, actually, this is going to be a power pin going out. That's going to be our ground. And now we need to create a footprint. So far we've only worked with a schematic, but we're going to create a actual physical layout of our board too, which is what you're going to solder together. And so for that, we need a footprint too. So I'm going to create a new footprint and label this CMT-1285-C-035 underscore buzzer. And here the dimensions matter quite a bit. So we first want to start with our through-hole pads. And if you look here, it's saying that the pins are 0.6, and this is units of millimeter, plus or minus 0.01. So we want to go a little bit bigger than that for our pins. So like 0.7 millimeter would be good for the pins. And then they are 6.5 millimeters apart. So I can either place an SMD pad or a through-hole pad, and these are through-hole components, so I'm going to click through-hole. I want to change it to round, and I want to change my size. Now, it's currently in mils or thousandths of an inch, but if I just type in 7 mm and press tab, click out of it, 0.7 mm is better, then it'll convert it to mils for me. So I'm going to just place two for now, one below and one above my little plus here. That's my origin, my 0 point. And then looking at this, it is 6.5 millimeters between pins along, and my origin is kind of in the center. We need to make a determination point of where our origin will be, and the center is a pretty good place for it. So that means I need to go 3.25 millimeters up and 3.25 millimeters down. So I'm going to click on my first pin, and this is my X position and my Y position. So I'm going to type 3.25 mm for my Y, and then click on my lower pin and do negative 3.25 mm, and there is our pinholes. Now we also want to draw a circle around to show the diameter of the speaker itself. So I can go to draw and circle, and come out and just draw a circle of any size for now. Now, if we look at our data sheet, it's a 12 millimeter diameter circle. So I'm going to click on my circle, and I'm going to change my radius. Notice radius, not diameter. So 6 mm, and that gives me the proper diameter. All right, now we're going to click. So we've created our footprint. We've created our schematic. Now we have to link them together. So I'm going to create new component and label it just like before. And first I'm going to bring in my footprint. So I'm going to click add. And because this library only has one device so far, I'm going to just select the one that exists and place it kind of in the middle on my origin. Now I'm going to go down to new, add local package, and add the footprint that we just created. Then I'm going to, so I have my footprint added. It's right there. And we need to associate these pins with these holes. So I'm going to click connect. And I can just link pin 1 and pin 2. So those connect each other, and click OK. Now this doesn't have a 3D model, and we do want a 3D model, at least a simple one. So I'm going to click the drop down here, right click on the device, and click create new 3D model. And we can just click save. And we don't need to do something fancy for this. Really, we just need for our enclosure the size of the speaker. So we can see it's a 12 millimeter by 8.5 millimeter cylinder. And so let's just go ahead and draw that. I'm going to click solid, create sketch, draw on my front plane, draw a 12 millimeter circle, and extrude it 8.5 millimeters. You can see that goes up. That's good enough for what we need. So I'm going to close out of this, and it's going to automatically save. And you can see that's going to link it to my model. So there it is right there. Yep, we have our buzzer. And then I can go ahead and save this library. Now I'm going to just name this EW200 library, because we're going to add another component to this soon. All right, let's go ahead and go back to our schematic and add that speaker that we created. So let's find the library we just made and find the component that we just made and bring that in. All right, we're going to need a ground on the bottom. And then the top is going to go to a pin. So I'm going to click R to do nets and just draw out a line. N for name, and name it. We're going to hook this up to GPIO 9. Same thing. I'm going to find GPIO 9, draw out my line, and name it GP9. All right, so that is connected. Next up, we're going to have, in our last device, we're going to have a 3-color LED. So in DigiKey, I'm going to search 1830-1015-ND. That's going to bring up this 3-pin LED that we have here. Let's go ahead and go to the data sheet. And we're going to scroll down, and there's some information about it. And we're going to get to our dimension drawings, which is great. So we have what the schematic symbol looks like, and then what the actual LED dimensions are. And, oh wait, I have dimensions for another LED here too. But we are an HV-5RGB25, and this is RGB60. This is RGB25, so this is the one we want to use. going down more, there's some data about the actual LED that you can look up. But really, for now, all we care about is this dimension sheet here. So let's go ahead and recreate this schematic symbol in our library. So I'm going to go back to EW200 library, click new symbol, and label this HV-5RGB25 underscore LED. All right, we're going to create one pin, so I'm going to rotate, and that's going to be my common or my ground or my cathode. And then I'm going to create another 3 pins below that for my R, G, and B. All right, we're actually going to drag this down a little bit to give us some room, and we're going to drag them in one so that there should be 2 spaces in between each. Let's go ahead and name these. So I'm going to click on my first one, and I'm going to name this COM. And I'm actually going to name it 3COM because we can see this is pin 3, and by putting 3COM, it just makes it easier when we have to attach our pins. And then I have my first pin, which is 1 blue. So I'm going to just go 1B, B for blue. And then I have pin 2R. And then this is pin 4G. And again, I'm just going off of my data sheet here. All right, we do have to create that symbol. So let's go ahead and draw a line. And I'm going to come down. I'm going to make this a straight line. I'm going to come down a little bit. And I'm going to branch out. All right, and then I'm going to come up a little bit. And now we're going to make a triangle. I can go to polygon shape. And I never use this, so I always forget how it works. You know, I'm actually going to just use the line tool. I'm going to select this angled line here. And I'm going to just draw my triangle. Yeah, those don't look very good, so let's redo those. And actually, I was wrong. I do want those spaced 3 out. Oh, geez. All right, and then we need a line over top of them, which is kind of the symbol for an LED. And then let's connect everything. Oh. All right. And there is our LED. Not the best looking LED I've ever drawn, but it's going to work for our purposes. Now, let's go ahead and make the actual physical footprint. So I'm going to click New Footprint and type in the name of this. And do through hole components. So we can see each of our pins is 0.5 millimeters. Or 0.02 inches, but we're going to stay in millimeters and just do 0.5. And so I'm going to do a hole size of 0.6 millimeter to be a little bit bigger. And then I'm going to place my pins. So I'm going to just go 1, 2, 3, 4. And let's make sure those are lined up correctly. So in the middle, I have no pin. And then in between each pin is 1.27 millimeters, which if I divide by 2 is 0.635 millimeters. So I want my first pin to be negative 0.635 millimeter. And then my next one is going to be 0.635 more. So that's going to be negative 1.27 millimeter. That doesn't look quite right. Let's go back to my data sheet. Oh, no, I was wrong. Sorry, it's 1.27 millimeters in between each one. I don't know why I divide that by 2. So I'm going to just do negative 1.27 millimeter, which is 50 mil. And then, so then 100 mil, and then 0 mil and 50 mil work for that. Now, I do want these centered. So I'm going to actually drag this over and then do negative 25 mil. Negative 75, and then plus 25, and plus 75. All right, let's go ahead and draw our circle to be our LED. And this has a radius, looking at this, of 5.85 millimeters. So that is 5.85 divided by 2. So 2.925 millimeter. 2.925 millimeter. And there's my LED. And then LEDs do have a flat on one side. And I do want to represent that in my drawing. And so I'm going to just draw a line kind of down there. And then I don't think I can trim, so I'm going to just leave that as is. All right. Let's go ahead and create our component for this. And then add our symbol. Oh, I did forget one thing, so let's go back to our footprint and go back to our device, and I want to change these names to be more descriptive. So this is going to be pin 1 is 1B, pin 2 is 2R, pin 3 is 3COM, and pin 4 is 4G. All right. Now we can go back to our footprint, to our component. Double click on our component and click New, add local package, and add our footprint. Let's click Connect. And this is why we named everything, because our pin and our pad have similar names. So it's really easy to just make sure they're connected properly, and click OK. All right, let's create a 3D model for this. So I'm going to click the drop down, right click on my footprint, and click Create New 3D Model, and click Save. Now, Fusion has a package generator for common devices. So I'm going to click Package Generator, and I'm going to scroll down and down and down and down, and there is a radial LED. There's a lot of different components that are good to look at, but we want our radial LED. The body, we want white, and then we're going to have to get from the data sheets each of these values. So E is 0.5. E is actually 1.27. And then B is 0.5 mm, and I forgot that, mm. And then C is also 0.5. Now we need to do the body. This is really the part that matters. So for this, it's 4.9 mm for our minimum size. And this doesn't really give us, I mean, it does give us a tolerance of 0.25 millimeters. So I could do 4.9 minus 0.25, which is 4.65 millimeter for my smallest. And then 4.9 plus 0.25 is 5.15 millimeter. And then A is the height, which we have 8.65 millimeter. And then A1 is going to stay at 0. I'm going to click add. And there it created our LED for us. Now, it's not perfect. It has 2 pins, not 4. But again, we really don't care about that. We care more about the top of it to make sure that when we make it in our enclosure, we have an accurate 3D model. And so this works for our purposes. So let's click finish. And then I'm going to Control S to save our library. And then I'm going to go to my schematic. I'm realizing I forgot a box for my buzzer. All right. And then let's come over here and place that LED. Just spin it around because our GPIO pins are going to be on top and our ground is going to be on the bottom. Now, just like we had here where we had a resistor in series with our LED, we need resistors in series with our LED even for a 3-pin. So I'm going to go to resistor again. And this time I'm going to select a 7.2 millimeter pitch axial. And I'm going to place 3 of them, 1 for each pin. Let's go ahead and connect them. And then give them a value. So V for value. And I can click on each and do 220. All right, and then I have to connect ground. And then these are going to be my GPIO pins. So I'm going to just come up. And these are going to be GPIO 20, 21, and 22. I'm going to rotate it so it's kind of vertical with it. And let's go ahead and place that. All right, go to name and GP22. GP21 and GP20. All right, let's go ahead and draw a box around that. Put a label and make this RGB LED. All right, so there we have our schematic completely made. We do want to make sure there's nothing wrong with this though. So I'm going to go to errors. I'm going to click update. And we have a couple errors here. So unconnected input pin on U1 run. The board is saying it's saying that we need something connected to that, but that's not true. So we can just improve it. Same with ADC ref and 3.3 volt and VBus. Part 3 or R3 has no value. So nice catch. I'm going to click V on my keyboard and click on that and give that a value of 220. I'm going to just refresh. And then each of these are okay. It's just kind of errors with the Pico saying like, hey, this pin shouldn't be power, even though it should be power. So I'm going to approve. All right. Let's go ahead and go to place components, click the drop down, and where is it? I always forget what it's called, but we're looking for our title block. Frames. Sorry about that. And we want a frame B. Should be big enough. And there we go. We have our object. All right. So we can go ahead and print this as a PDF. And then our landscape is, or our orientation is landscape. Alignment is center. Area is full. And I want to scale this, say 0.5, just as long as it's on one page. And I can click OK, export this, and this then is done. Oh, I did forget to change my title. But if I click Control S to save this, and I can click Save, and it'll update it. All right. So that's it for our schematic. Now, thank you for watching this tutorial. If you would please like and subscribe to this channel and this video to help me make more of these tutorials.